Good morning, students. Today I'd like to go over 7-2.5 guided notes for our pre-calculus classes, period 4 and period 6. Okay, so I will post the guided notes in the guided notes video today, and I'll post the solutions video on Friday. So I'm really excited. This is our last lesson. This is the most exciting lesson to me, and hopefully you'll see why in a few moments. So once again, our main focus of this chapter is to find particular equations of different types of functions that are important in calculus. They're really just important in general mathematics to describe most practical things if you ever had to use them. And finding a particular equation for a specific points of data will and modeling it as the correct function will allow you to stop using expensive methods to extract data points, and then you can, it's not going to be perfect, right? Just like the COVID-19 exponential curve is not perfect. It's changing every day because the data points are changing, but it gives you a good idea of how fast something's going to grow or what type of behavior whatever you're talking about is behaving like. So for pandemics like the COVID-19, it's an exponential. For trajectory motion, it's parabolas. So for anything from firing a bullet, firing a missile, a rocket launch, any projectile motion, basketball, tennis ball, football. Okay? So this is a quadratic function because the function has a vertex, which is unique to quadratic functions, and the function is increasing, then decreasing, and it is concave down. Okay, you can consider this the cave, and the cave is facing down. What's the general equation of a quadratic function? That's why we want to know if it's a quadratic or not. Y equals ax squared plus bx plus c. Notice that we have three unknowns coefficients. So if we want to create a particular equation, then we need uh, 3 points of data. And that's just a mathematical fact. And anytime you want to solve for 3 unknowns, you need 3 sets of data. Okay? So let's go down here and set it up. Once again, we're going to substitute our 3 points into the general equation, creating 3 different equations. But we still don't know what A, B, and C are. And that's what we're trying to find. Now for linear, we subtracted the equations. For exponential and power functions, we divided. For quadratic functions, we have to solve a system of 3 equations. Now, if you ever solved any type of system of 3 equations by elimination or substitution, there's a lot of room for error. I never really know if I'm sure about doing it correctly because, you can start with these 2 equations and subtract them, and then C will become 0, and then you multiply this one by -4, and then you can, eliminate the A, and then you have B equals that, and you substitute it back in, and then you solve for B, and then you substitute that back into C, and it's just very confusing. So what we're going to do, we understand though that method works. So what we're going to do is we're going to put these 3 equations in what's called a matrix form. Okay, so this is a 3x4 matrix because we have 3 rows and 4 columns. So we're going to just leave out, and what's good about a matrix is that it leaves out all the non-essential information. All we really care about is the coefficients in front of our unknowns. Okay, so here the coefficient is 1, 1, 1, 76. So we create a matrix A with the first row 1, 1, 1, 76. And we do the same for the second and third equation. 4, 2, 1, 89. 4, 2, 1, 89. 9, 3, 1, 94. 93194. If the coefficient isn't shown, then it is 1. I made a mistake here, so I didn't want to add any information because I know this is already pretty complicated. Now I could show you how to algebraically solve a matrix, but that's a whole nother chapter. It's called matrix algebra, matrix manipulation. We really don't have time for that. But just like when you use, let's say we're gonna use two methods. We're gonna use the TI-84 plus CE, and we're gonna use GeoGebra Classic. Okay. And I'm gonna show you GeoGebra Classic first. Okay, so then you say, well, Mr. Fernandez, how did I know that's gonna work? Well, how do you know that 9 times 4? You didn't solve that algebraically. You used the TI-80 and you trust it, right? But you didn't go 9 4 times and then add it up and, oh yeah, that's 36, right? If you write it down on a piece of paper and you're using symbols and you're working with your mind and you're adding, that's algebra, right? If you're using something like the TI-84 Plus, then that's a computational method. You're using a computer-aided tool to help you solve, but you have to know in the background what you want to do first. And that's the important part. That's where humans come in, right? We can make all these fancy tools, but if we know how to use them and we don't know when to use them, then they're worthless to us. They're just paperweights, what we used to call paperweights in engineering. So let's go and, okay, so I have the two methods down here, and I'm so dumb. I didn't write the general equation here, so we're gonna have to write it somewhere, the answer. Okay, but here are the methods. So in the TI-84 CE app, we'll go through this method and hopefully this will make sense. And then for the GeoGebra, we're going to use what's called the reduce row echelon form to reduce this matrix A into the 3 coefficients that we need. And so what this is doing is we're solving a system of 3 equations. Now you're saying, Mr. Fernandez, what does that mean? Well, let's go ahead and enter the 3 equations in GeoGebra, and I can show you what it means. Okay, so here what we're going to do first is we're going to say, now GeoGebra doesn't understand A, B, and C. All it understands is X, Y, and Z. So we're going to replace A with X, B with Y, and C with Z. Okay, so here we go. Let's go. Okay, so the first one is X plus Y plus Z equals 76. Then we're going to go 4X plus 2Y plus Z equals 89. And then we're going to go 9X plus 3Y plus Z equals 94. So we're using the computer to solve our problems because the algebra is too complicated. Okay, I'm going to change the color on. So these represent a plane in 3-dimensional space. Okay, so I'm going to use red, blue, and green. Blue and green. Just because those colors make up every other color and they're distinct from each other. Okay, so now let's go ahead and view what that means. Okay, so I want to say, okay, so we're not solving for the particular equation yet. We're just solving for A, B, and C, and then we'll write the particular equation. Okay, so when we're using GeoGebra right now, not to verify our answer yet, we're using GeoGebra as an intermediate tool to get to our answer, and then we'll verify it using GeoGebra again. So we're using GeoGebra twice. Okay, and we're going to use the TI-84 twice. Okay, so now let's go to view. I didn't sign in, but that's all right. Okay, so let's go to view. I'll save afterwards. I'll sign in and save. We don't really need these graphics right now because we're working in three-dimensional space. Let's use three-dimensional graphics. Okay. Oops. Okay, so there's the three-dimensional graphics. And if we zoom in, we should begin to see the planes. Okay. And so we have two, and the third one should come in soon. Where's the red one? Let's see here. So let's, okay, there's the red one right there. Okay, and I kind of know where they intersect, so I'm gonna manipulate this. Okay, so now, but where's the solution? This, it's kind of hard to see. Okay, where's the point? Where's my x, comma y, comma z, where these three planes intersect? It's somewhere right here, right? Okay, so let's say, well, we're gonna have to do something here. Let's use reduced row echelon form. Okay, so we're gonna type in reduced row echelon form, and we're going to write it just like I have. We need two squiggly brackets. And we're gonna go and we're gonna input our matrices just like on our notes. So 1, 1, 1, 76, squiggly, close squiggly bracket. It's called a curly bracket, I'm sorry. Okay, and then open curly bracket, 4, 2, 1, 89. It closes the curly bracket for me, comma, because I'm separating the different rows and the different rows and columns. Open curly Q bracket, 9, 3, 1, 94. Close curly Q bracket is already closed. And then we have to close it again because we're encompassing all of the matrices. And then we have to erase this because this is like a generic matrix, so that you don't forget to put a matrix in there in the proper form. Okay, let's drag this out a little. So once again, this is an intermediary step. This is not, we don't have the particular equation yet. We're almost there though. Okay, so let's select this and hit enter. And so it's solved. So there's our X, Y, and Z. Now, in order to see that, and remember, GeoGebra only understands X, Y, and Z. So this is actually A, B, and C. Okay, now I say, well, where is that, Mr. Fernandez? What is, because, we're solving a system of three equations using matrices and reduced row echelon form in a computational tool, right? So we know that it would work if we did it algebraically, but we also know that we're prone to mistakes. So we want to use a tool so we don't make mistakes. So let's call point. So this is saying that these three planes in three-dimensional space intersect at -4, 25, 55. And let's see if that's true. And I'm going to make this color white so that we can see it clearly. And it'll contrast with the other. And then I also want to make the style a little bigger so I can, really see it. Okay, and then okay, so now let's look and see. This is what it means to solve a system of three equations. Just like when you solve a system of two equations, it's where, let's say you're solving a system of two lines, right? Two linear equations. If you draw the lines, that point where they intersect means that's where they're the same. That's the solution, where they're all the same. So if we look at this point right here, you can see clearly that the blue plane intersects the point, the green plane intersects the point, and the red plane intersects that point. Okay, we could probably go a little closer and see it even more clearly. Okay, yeah. So we can see that that point intersects and that's the only point in space. That's the only point in three-dimensional space where that intersects. Okay, so now let's say, okay, so now we can write our um, solution. Okay, so let's stop this at a good point right there where we can kind of see where all three planes intersect. Okay, and now let's write our particular equation. So y would have to equal minus 4x squared plus 25x, right, plus 55. Okay, and then we can see, and let's make this color, let's make it black so that we can like really see it. Right, so it can contrast versus everything else. Okay, and then we'll close this, we'll close that, and then we can see it in three-dimensional space somewhere. Let's see, we probably can't see it. Okay, we don't need to see it in three-dimensional space because these are two different solutions. The three planes intersecting at this point gives us the coefficients of our particular equation. Our particular equation now we have to compare to our given information, which is the original graph here. Okay, and so let's look at the scale here. So now let's go to, now let's turn the graphics view on, and we're going to turn the three-dimensional graphics view off because we don't need that anymore. And there's nothing there. But yeah, our coefficients are pretty large. So the y-intercept is 55. So that means the y-intercept, right? This last number is 55. So for the parabola, right? So if you look up here, that's 55. I kind of drew it wrong. Huh? Should be 55. Anyways, okay. That's why we use computational. Okay, let me see. Why isn't it showing? Maybe. Let's see here. -4. Y equals -4x squared plus 25x plus 55. That should be a parabola. Let's see. Maybe it's going crazy here. Oh, there it is. Okay, for some reason, it's weirdo on me. Okay, so let's look at the. I'm not sure why. Oh, I did the fill. I'm sorry, I did the fill. I did the fill as let's just. Can we reset? Oh, with my style, something different. Non-thickness, opacity. Oh, opacity. I don't know why the opacity is that much. Okay, so line dash standard. Okay, well, I don't want this video to get too long. Not sure what happened here, but let's see, 0. Okay, and then I want it to be black, but gray is good. Okay, gray is fine, I guess. That's fine. Okay, so now let's take a look up here, and so this is a 1 to 10, right? So it's a 1 to 10. So x is 1, y is 10. So let's go to GeoGebra Classic, and we'll go double tap with 2 fingers, or single tap with 2 fingers on the, so this is the ratio of x to y, 1 to 10. So x to y is 1 to 10, and we should have a pretty good picture of our, okay, so I think we did it. Okay, so let's move it down so it looks kind of like what we see on our paper. Okay, so like we go from 0 to 9, and then it goes from to about 100, right? 80, 100. So that's pretty good. Okay, now let's see if our points pass through it. So our first point was 1, 76, because we want to verify multiple ways, right? We don't want to just leave it up. Oh, boss, yeah, I think I got it, boss. The boss doesn't care if you think you got it. The boss wants to know, do you got it? And can I trust you? Can I leave you alone so I can go make all the money and try to pay you less? And you say, well, hey, if I did it right, well, if you want this right answer again, I think a raise is in order. You don't tell them like that, with all due respect, sir, I feel that I should have a raise because I'm the one that's doing all this work for you. And I'm the one that you're trusting basically with your business. And so all 3 points pass through the particular equation that we found by using matrix math, reduced row echelon form, to solve us, first of all, our system of 3 equations, right, with 3 unknowns. And that's the technique that we're using, right? So this is not an algebraic technique. This is a computational technique, what's called a numerical technique, because we're strictly using, we're kind of crunching the numbers in this numerical and using a computer-aided tool. Okay, so that looks good. Let's see. Our vertex is D, about 55, right? We could probably say, it's about 55, 8, and almost -2. Okay, so 8, almost -2, 55, vertex is 394. It looks pretty good. Okay, so there's the answer. I didn't write it on the guided notes. Can you please add that to your notes? Okay, one other quick wit method, okay, to use. I know this video is getting long, but I want to show you 2 different methods. Okay, we're going to go to second matrix here, and you're going to go over to the edit button, press enter. We're going to, just like our notes said, we're going to use a 3x4 matrix, and we're going to choose to edit matrix A. So this is going to be 3 by 4. Okay, and then enter. And now we're just gonna, I'm gonna use the keyboard here. I'm gonna go 1, 1, 1, and I'm gonna enter each time. So 1, enter, 1, enter, 1, enter, 76, enter. 4, enter, 2, enter, 1, enter, 89. 9, enter, 3, enter, 1, enter, 94. And then enter. Okay, so now we've edited matrix A in the TI-84 plus CE app. So now let's go second, quit. See the blue quit. Okay, now let's go second, matrix, and we're looking for matrix math now. Which matrix math do we want to use? Let's go down and find reduced row echelon form, which is RREF. We're going to hit enter. It's going to want a matrix to mathematize, I guess you can say. So let's go to second matrix. We're going to go to names, and we want matrix A. That's the one we edited. We're going to close parentheses, and we are going to hit enter. And we have -4, 25, 55. So those are our coefficients for a lot easier on the TI-84. But if you don't know how to use the TI-84, it's like, at least here you can see what's going on. You can see that the solution to a system of 3 equations is the 3 planes intersecting, right? That's the geometrical solution to it. So let's turn this off, and let's turn back on the 3D graphics. And in fact, we can just turn off the algebra too, because we don't really need that anymore. And let's leave this one on. All right, so I can kind of start the rotation, I think. I won't rotate. Oh, you can go up here, rotate graphics view. I guess I won't do it today. Okay. All right, so that's, so like the TI-84 CE plus, yeah, okay, you understand matrices, you understand, but you can't see it. You're like, I'm doing it, I'm getting my points, yeah, I passed the class so I could become a sociologist or whatever you guys want to call it, be whatever. But if you really want to truly understand it, I really think that you should understand the geometry. I hate algebra personally. I don't hate it, but I like solving things geometrically because it's just I'm a visual learner, and it's just seems like it's more clear. You actually understand it instead of just doing like a robot. Because you don't need robots, you need a human. So now let's just one last time. Let's go ahead and what's this? -4, right? So let's go negative, and I'm using the keyboard here. Okay, -4 x squared, right? So x to the I could just use this one, but anyways, squared. And then we use the right arrow key to escape that. And then plus 25. 25, I think, right? 25 x plus 55. Plus 55. Okay, let's go enter. And then we're going to change our window right away. So let's go to window. And what is our minimum? Minimum was -1. So let's go -1. Our maximum was about 10. Yeah. For X max. The scale was 1. Our Y minimum was -10. Okay, so that's good. Our Y minimum, our Y maximum was 100 on our paper, and I'll show you right now. And remember, our X to Y scale was 1 to 10, right? 1 to 10, yeah. So for each one the X goes, Y goes 10. And now if we graph that, we can see it's pretty close to our paper, to our original given. However, we can't manipulate it. We can't see the three-dimensional planes intersect. We can't, it's kind of hard to see what tick marks are here, so it's not very precise. It's very precise, but you have to really learn how to use this. I still like the TI-84. It's very compact, and you need it for SATs, ACTs, big tests. Okay, so this video did get kind of long, but I was kind of excited to show you a pretty complicated method, and I hope I broke it down for you so that you can understand. And these are the notes. I know I never mentioned how you're going to prove that you show it in the TI-84 plus CE. I just didn't get there. The distance learning, I'm still learning as well. And, I just didn't know how, maybe I should have said, shoot a screenshot of the, of the GeoGebra, and shoot a screenshot of the TI-84, and to show, to finish out the assignment. However, I didn't, and I didn't want to change. Once I became consistent, and students, the most important thing was that you were participating, so that I can give you the best possible grade. Notice that this is on the 2 dimensions, right? It's like on a flat piece of paper. This point is in 3 dimensions, and notice that those are the 2-dimensional points that pass through our solution here. Okay, and so that this is the parabola here that's here. Okay, congratulations. Please finish. I make these videos long and complicated, but it's not too difficult to copy down these notes. I hope you realize that I didn't write everything in the notes, right? I didn't write the particular solution, and the things that we discussed in this video, or at least the things that I share with you in this video, are more than what's on this paper. Okay. I can't, once again, your seniors, most of you, except for one, I think, are going to go on and move on in your higher education. My only advice to you is, it's not what the teacher says, it's what you say. You're the one that makes your education possible. So good luck, and email me if you have any problems. I would love to help you. And I'm trying to stop this video, and it's not working. So kind of awkward. Okay, have a great day, students.